now we will discuss descriptive statistics, tabular and graphical displays, how to summarize categorical data using tables and graphs, and how to summarize quantitative data using tables and graphs. So the data can be classified as either categorical or quantitative. Categorical data use labels or names to identify categories of like items, and you can either use labels or names to identify categories of like items, or you can use numeric code. Quantitative data are always numeric, that indicate how much or how many. So now we will discuss how to use tables and graphs, tabular and graphical displays for summarizing both categorical and quantitative data. For categorical data, we can use frequency distribution, relative frequency distribution, percent frequency distributions. These are tabular displays. Or we can use bar chart, pie chart, and these are the graphical displays. So what's the purpose of the frequency distribution, and how do we obtain the frequency distribution? Frequency distribution, which is a tabular summary of data, it shows the number of observations, or frequency of observations in each of several non-overlapping categories or classes. And the objective is to provide insights about the data that cannot be quickly obtained by looking only at the original data. Such as here we have categorical data. Guests staying at Marada Inn were asked to rate the quality of their accommodations as being excellent, above average, average, below average, or poor. So 5 different quality ratings. And we have 20 guests provided. We have a sample of 20 guests. These are the ratings. How can we summarize this data? Now we can obtain the frequency distribution. So how many poor ratings do we have? 2. How many below average? You count the frequencies, count the observations in each of the classes, categories. So you have total 2 poor ratings, 3 below average, 5 average, 9 above average, and only 1 excellent rating. This is the frequency distribution. So that provides some insights about the data that cannot be quickly obtained by just looking at the original data. Such as from this one, now we have 9 above average rating, 2 poor ratings, and only 1 excellent rating. We can also obtain relative frequency and percent frequency distributions. Relative frequency is a fraction, which is we can obtain the relative frequencies for each class, which is a fraction of the total number of data items belonging to that class. How do we obtain the relative frequency distribution? So now, since we have the frequency, to obtain relative frequency, which is 2 divided by 20. Three divided by the total 20. Five divided by 20. Nine divided by 20. And 1 divided by 20. Sum of the relative frequencies must be 1. And the percent frequency distribution provides the percentage. What percent of poor ratings do you have? It provides, and once you have the relative frequency, you can easily obtain the percent frequency, which is the relative frequency times 100. It provides a percentage of the items that belong to this class. So 10% poor rating, 15% below average, 25% average, 45% above average, and 5% excellent. So total is 100%. So relative frequency shows the relative frequency for each class, and the percent frequency shows the percent frequency for each class, which is relative frequency times 100. We can also obtain bar chart, which is a graphical display for quantitative data. For this example, the bar chart is look like this, like poor, below average. Graphical displays usually preferred over the tabular displays because it is clear. Now we know that mostly we have above average rating. We don't have many excellent ratings. We can also obtain bar charts and a pie chart. So this is the bar chart. This height gives the frequencies, and you have each classes here, and the height gives the frequency. We can also obtain the pie chart. It's also commonly used graphical display for categorical data. So you have the circle 360 degrees, and how do you, such as if we look at our data, we have such as 25% average rating. Then how do we represent this here? So 25%, which is 90 degrees. So this means the quarter of the circle would be average. So this is how you subdivide the circle into sectors, which the pie chart for this example look like this. And now what are the insights we gain from these summaries, or would you be happy if you are the manager of the Marada Inn? So it is good that they have 45% above average rating, but also they have 5% excellent, 10% poor rating. So for each excellent rating, they have 2 poor ratings. So poor rating is twice as much as the excellent rating. So that is something they need to address. So also summarizing quantitative data. Before we discuss the quantitative data, so let's look at Excel. How do you obtain bar chart and pie chart? So we select the data and go insert. You can change the title. You can also change the field color and put different field color for each class. Which will look better. And also you can change the design, whichever design you like. And how do we obtain pie chart? Again, we select it, insert, and here you see the charts. You can select this 2D pie chart or 3D pie chart. You can change you can select whichever design you like. It is important to put a clear title. This is good. This looks good. Now we will discuss how to summarize quantitative data. So we can use frequency distribution, relative frequency, and percent frequency distributions. We have more alternatives for quantitative data. We can also use cumulative distributions, dot plot, histogram, and stem and leaf displays for quantitative data. And the frequency distribution, so now we will start with the frequency distribution. The manager of Ch02 would like to gain a better understanding of the cost of parts used in the engine tune-ups performed in the shop. She examines 50 customer invoices for tune-ups. The costs of parts rounded to the nearest dollar are listed. So 50 tune-ups. Now we need to summarize this data. Now previously, if we had the categorical data, we already knew the categories. Here the classes are here. So we just count the number of occurrences. But now for the quantitative data, now how can we obtain the frequency distribution? We need to determine the number of classes, width of each class, upper and lower limits of each class. So, and here there are some guidelines to determine the number of non-overlapping classes. The purpose is, the goal is to use enough classes to show the variation in the data, but not so many classes that some contain only a few data items. Usually it is recommended using between 5 and 20 classes, depending on the number of elements in the class and depending on the data set. If you have data set with large number of elements usually require a large number of classes, and smaller data sets usually require fewer classes. And then once we determine the number of classes, then you need to determine the width of each class. And also, you should make the classes, you should use the same width for each class. That would reduce the chance of inappropriate interpretation. So it is also recommended to use the same width for each class. And also, you can determine in practice number of classes, and the appropriate class width are determined by trial and error. Just for large data sets, you can use statistical software, and you can easily change the number of classes and the width of each class, and you can obtain different tables, and you can decide which one represents the data better. So you can use your judgment to determine the combination of the number of classes and class width that provides the best frequency distribution for summarizing the data. And then the class limits. How do you choose the class limits? So class limits must be chosen so that each data item belongs to one and only one class. The lower class limit identifies the smallest possible data value assigned to the class, and the upper class limits identifies the largest possible value assigned to the class. For example, for our example, now these are cost parts. These are the dollars, costs. Sample of parts costs. So now, and we have only 50. So here, you can choose whether you wish to do such as $10 increments or $5 increments. Here, and also here, the data ranges from smallest value 52 and largest 109. So you can use, for this case, I think it is appropriate to use $10 increments. So now, so how do you determine, such as the first class cannot start with 53, because if it starts from 53, then we have 52, so we are leaving it out. We cannot leave any data, any observation out. So it cannot start from 53. So we can start this from 50 to 59, and 60 to 69, 7 to the 79, 8 to the 89, so we have 6 classes. Now we can obtain the frequency distribution, which now we count. How many do we have in this class? How many do we have in 50 to 59? We have 52, 57. We have 2. And you do this for all classes, like how many do you have? 6 to the 69. You count all of them and obtain the frequency distribution. So this is the frequency distribution. And then once you have now, how do we obtain the relative frequency distribution? So the total is 50. Once we have frequency, we can easily obtain relative frequency distribution. And the percent frequency distribution. Now this is 2 over 50. 0.04. 13 over 50. 16 over 50. 7 over 50. Sum must be 1. And the percent frequency is relative frequency times 100. So 4, 26, 32, 14, 10. So we have only 10% of the parts are price 100 or more. 4% price 60, less than $60. So these are the insights we gain from this tabular summaries. Frequency distribution gives the number of observations in each of the several non-overlapping classes. We have 16 in this price range, 5 in this price range. This is the relative frequency and the percent frequency distributions. And these are the insights we gain from the frequency distribution. 4% of the parts costs are in the 50 to 59 class. 30% of the parts under 70, so 26 plus 4, 30% is under $70. And greatest percentage of parts is in 70 to 79. And 10% of the parts costs are $100 or more. Also, we can obtain some graphical summaries for quantitative data like the dot plot. Here we have horizontal axis which shows the range of values, data values, and each data value is represented by a dot. The dot plots show the details of the data, and it is useful comparing the distribution of the data of for 2 or more variables. If you have 2 or more variables, you can obtain the dot plot to compare the distribution of the data. For Ch02, this is the dot plot, and here we see the distribution of the data, such as here, most values are accumulated here. We don't have much after 105, only 1, and here it's not, only 2 of them, less than $60. Yeah, this dot plot is simple, easy to obtain. It's a graphical display and shows the distribution of the data. And histograms are commonly used graphical displays. Before you obtain the histogram, you prepare the data. You can either obtain the frequency distribution, relative frequency, or percent frequency distribution. It's similar to the bar charts, but histogram is for quantitative data and bar chart is for categorical data. For Ch02 example, this is the histogram. Here we see also which the height gives, in this case, frequencies for each class. Also, the histogram, they provide information about the shape or form of a distribution. If it is skewed to the left, if the histogram is skewed to the left, then this means the tail extends further to the left, then it is called negatively skewed or left skewed. If it is skewed to the right, like this is left tail, this is the symmetric because the left tail is the mirror image of the right tail. This is not skewed, this is symmetric. You can have right skewed, you have longer right tail, but this is not highly skewed because you don't have very long right tail. It's moderately skewed, moderately right skewed. And this is highly skewed right. You have a very long right tail. For example, executive salaries. Most salaries are around this price range, but you have very few, but very high salaries towards to the right. We will now discuss the cumulative distributions. For categorical data, we have frequency distribution, relative frequency, and percent frequency distributions. But for quantitative data, we can also obtain the cumulative distributions. And the cumulative frequency distribution shows the number of items with values less than or equal to the upper limit of each class. So if we go back to our example, Ch02, how many do we have less than or equal to 59? How many do we have less than or equal to 59? 2. Now, how many do we have less than or equal to 69? We have 2 here, plus the 13 in 6 to the 69, so then it is 15. It's the cumulative frequency. The purpose of obtaining these cumulative frequency distributions is to provide additional insight about the data. How many do we have less than or equal to 79, to 15, less than or equal to 69? Plus we have 16 from 7 to the 79, so it is 31. And how many do we have less than or equal to 89? We have 31, less than or equal to 79, plus 7 from 80 to 89, 38. And how many do we have less than or equal to 99? Which is 45. 38 plus 7, 45. And the last entry must equal to total number of observations, which is 45 plus 5. This is the cumulative frequency. We can also obtain cumulative relative frequency distribution. The cumulative and also cumulative percent frequency distributions. what's the proportion of values less than or equal to 59, which is 2 over 50, 0.04. And what proportion is less than or equal to 69? 15 over 50. What proportion less than or equal to 79? 31 over 50. What proportion less than or equal to 89? 38 over 50. And what proportion is less than or equal to 99? 45 over 50. And last entry is 1. How about the cumulative percent frequencies, which is the relative frequency times 100? We have 4% less than or equal to 59, 30% less than or equal to 69, 62% less than or equal to 79, 76% less than or equal to 89, 90%, and last entry is 100. This is it. So you can obtain frequency distribution for quantitative data. You can obtain frequency distribution, cumulative frequency distributions, like frequency distribution, relative frequency distribution, percent frequency distribution, cumulative frequency, cumulative relative frequency, and cumulative percent frequency distributions. These are tabular displays for quantitative data. Also, the other alternative for quantitative data is the stem and leaf displays. This is a graphical display. It is similar to the histogram, but the one advantage of stem and leaf display is to it shows the actual data value or approximate value. So you have first digit excuse me. So first digits of each data item are arranged to the left of a vertical line. So we have stem, which is the leading digit, and the leaf. Each digit on a stem is a leaf. For example, if you have an exam score such as 85, you have 80 stem, 5 leaf, and such as 87, such as 92, 9, 2. So you record it in the rank order. You have leading digit and the remaining digit, stem and the leaf. Now how do we obtain the stem and leaf for Ch02? For this example, so you have stem 5, 2, 7. Here now we see the each data value. So we have 52, 57, 62, 62, 62, 62, and the rank order, in rank order. So we can see the smallest value 52, largest value 109. And we can see the distribution of data, whether any gaps in the data. And also you can possibly see whether you have outliers in the data. But we will discuss the outliers later. We will discuss box plots. They are more appropriate to detect, box plots are more appropriate to detect outliers in stem and leaf display. And also you can change the display. If you think that the original stem and leaf has condensed the data too much, then you can stretch the display vertically by using 2 stems for each leading digit. So in that case, the first value corresponds to leaf values of 0, 4, and the second value corresponds to leaf values of 5 to 9. And if you do that, then stem and leaf, it looks like this now, 5, 2. The other 7 here, 6, 2, 2, 2. It looks like this if you can change the leaf unit. And leaf unit, the default leaf unit is 1. And the single digit is used to define each leaf, but we can change the leaf unit. Such as you can make leaf units 100, 10, 1, 0, 1. So the leaf unit, if it is not shown, it is 1. It indicates, the leaf unit indicates how to multiply the stem and leaf numbers in order to approximate the original data. For example, here, leaf unit is 0.1. So then this is 86 times 0.1. So the actual value is 8.6. But if leaf unit was 1, such as if leaf unit was 1, then this would be 86. If it is 1, so then this would be 86. Such as if leaf unit is 10, then that will be 86 times 10, 860. So it shows how to multiply the stem and leaf to approximate the original value. Here leaf unit is 0.1. So then this is not 86, but it is 8.6. And this is not 88, this is 8.8. And here leaf unit is 10, such as this is not 168 times 10, 1680. It's not actually, we don't have 1680, but it is approximate value, it's rounded. And next we will still discuss how to summarize categorical and quantitative data, but we will see, so in this lecture we only discuss one variable, we only add one variable at a time. And next we will discuss how to summarize categorical and quantitative data if we have 2 variables.